All right, ladies and gentlemen. So today we're going to start on new material. All right. All right, so similar polygons are shapes, polygons, that are larger or smaller versions of each other. Okay, they're the same shape, just bigger or smaller. So when you shrink something or make it larger or smaller, the lengths of everything are going to change. But the angles, if you can think about, you take a garden variety triangle and you make it larger or smaller, do the angles change? No, the angles haven't changed at all, but the lengths definitely have. All right, so the lengths change, but the angles stay the same. Also, if two objects are similar, now wait a minute, congruent is a little different than similar. Because remember, with congruent, all the lengths are the same and all the angles are the same. But with similar, things get bigger or smaller. Now, go back to congruent triangles for a minute. Do you remember what we said about angle, angle, angle? Was that on the good list or the bad list? That was on the bad list. Do you remember why? Remember why it was on the bad list?
Because it was, let me go back.
Well, that same kind of thing that I just talked about. Yeah, go back to old school stuff, right? If we had this object, Donkey theorem was the other one on the bad list. You see, but all of these angles stayed the same. So two objects that have all three angles the same, they can't be congruent, but they can be similar. And this was what we were talking about when we were talking about things on the bad list. There's something called a scale factor. A scale factor is the number of times one object is bigger or smaller than the other. So if something is twice as big, the scale factor would be 2. Okay? If something was half as big, the scale factor would be a half. Okay? That's the whole idea. It's how many times bigger or smaller. So if I said that two objects were similar to one another, then I know that if one of them is 3 times bigger than the other, all of the parts are 3 times bigger than the other. Okay? Every piece of of those shapes are exactly the same number of times bigger or smaller. Okay? So for example, if I wanted to find the scale factor, for example, let's do this shape. Now, actually, I shouldn't have used an equilateral triangle, and in fact, I'm going to change my mind on that one. It's okay. You all right over there? So for example, if I said this was 3 and this was, say, 5, and this was, say, 6, if those two objects are similar, if I give you that in the beginning and I say, oh, hey, by the way, those two objects, right away you know they're similar, then we can say to ourselves, how many times bigger or smaller is the first object from the second? It's 2 times as big. How do you know? I mean, you're right, but how did you come up with that decision? Okay, and now sometimes, if you have a strong command of your multiplication tables, you'll be able to look at that and say, oh, all right, well, 3 times 2 is 6. He's right. But sometimes the scale factor is not a whole number. It could be 1.5 times as big. Okay? It could be something like on a map. When you look down at the map, at the bottom of the map, there's a legend, and it says, 1 inch equals 1 mile, or something like that, right? Or you might see something that says say you have a model, model car, model boat, model train, whatever it is, on the bottom of that box, it'll say scale 1 to 20. So 1 inch on this thing is 20 inches on the real thing, So sometimes you don't know what the scale factor is. So if we don't give it to you, or if it isn't obvious like this one where it's just multiplied by 2, to get that number, you're going to take those numbers, that 6 and that 3, and divide them. Okay, so for example, six over 3 is my scale factor. Now, if they're similar, everybody's got the same scale factor. Everybody's twice as big. So whatever that scale factor is, it's true for every single piece. So if the ratio of 6 to 3 is 2, then the ratio of x to 5 should also be 2. Cross multiply and solve. This is why we practice the cross multiplication. And you should get what you expect. You were expecting 10, right? Because you were expecting it to be twice as big as 5. Well, guess what? It is. All right? Make sense? Now, if I gave you this as, say, 8, better yet, let's make it 10. What can we say about that? What's y going to be? What is it? It's 5, right? Because whatever y is, if I multiply by 2, I get 10, right? So we can set up a different proportion if we wanted to. Now, how you set up these proportions is really important. And I'm going to show you what happens when you do it the wrong way. Because I just did it the right way. But I didn't tell you how I did it. And I'm going to tell you that in a minute. So go ahead and solve for x and solve for y if you've already done it. Did you get what you expected? You got 5? All right. Now, here's what I'm getting at. I set up my proportion the right way. We all know that x is supposed to be 10, right? So secretly, I'm going to come over here and I'm just going to put that in here. Don't tell anybody, but x is 10. that cross product. So the cross multiplication and find me my x. I'm not sure. Check it out and try it. Do that. You did it the first time. Now do it this time. This is doing it the wrong way. What did you wind up getting when you got your answer? Not what you wanted, right? It's incorrect now, isn't it? You get 2.5 instead of 10, which was, so there is a right way and a wrong way to do this. Well, better yet, there are a lot of right ways of doing it, and there's one wrong way. Okay? Here's how it goes. If I went 3/6, I'm going from left to right. Okay? So if I'm choosing to go left over right, then I have to keep that pattern. Whatever pattern you choose, you have to stick with it. All right? Don't change directions in the middle of the problem. So if you're going to go 3/6, which is left over right, you're going to have to go left over right again. Now when you cross multiply, what do you get? The right answer. Okay? So if you're going to go left over right, stick with left over right. If you're going to go top over bottom, stick with it, top over bottom. All right? Whatever the situation, whatever pattern you choose, don't change it. So here I went left over right. Now let's see what happens if I go right over left. See if it matters. If I go right over left, x over 5 would have to be what over what? If I'm going to go right to left, x over 5, what would my other one be? 6/3. So it doesn't matter what direction you choose, just don't change it. Okay? In fact, I could have stuck within the same triangle even. I could have done 3/5. If I chose 3/5, what would I have to write on the other side? Well, which one? 'Cause, yeah, you know, you see how I chose, I said 3/5, you see that pattern inside that triangle? You're going to stick with that pattern. So 3 to 5 would be 6/6. So like I said, there are a lot, oh, actually, I'm not going to erase that. There are a lot of right ways of doing it, and there's one wrong way of doing it. Look over here. You see how I did? This was the wrong way. Take a look at my wrong answer, or my wrong setup, and figure out why it's wrong. Yeah, I went left over right in the first one, and then I went right over left in the second one. I switched it up, and that's what made it wrong. So whatever you do, keep it. Okay? All right. Now, all right, now when we were doing congruent triangles, we had congruent statements. You know, that said that triangle ABC congruent to triangle XYZ. Remember all that? All that stuff? We're going to have the same thing for similarity. But we have a different symbol now. Okay, remember, we've had a whole bunch of symbols at this point. You know, we've had congruent, we've had perpendicular, we've had parallel. Oh yeah, we've had lots of symbols, lots of different symbols. This one is the symbol for similar. All right. And like in the congruent statements, A corresponds to X, and B corresponds to Y, and C corresponds to Z, just like before. Okay? So if I talk to you about a segment or an angle in one triangle, you can look at the similarity statement and talk to me about the other triangle. Okay? So, for example, BC would be similar to who? YZ. See, whatever pieces you have correspond to the other guy. Okay? Just like congruence, no different, except they're not congruent, they're just similar. Okay? Now, we write this like this. Well, BC, like you just said, the length of BC is proportional to the length of YZ. Who would AC be proportional to? XZ. Good. And how about BC? Oh, no, I already did that one. I'm sorry, AB, my fault. Okay. This is the proportion that you will be asked to produce from time to time, okay? Showing all of the proportional parts. Okay? That's the proportion statement. Okay? How are we feeling about all? It's a lot like the similarity stuff. We good? Now, how about this? Let's do some problems. All right. Those tick marks on those angles are really a big deal. Because what they're telling you is how are the two triangles related to each other? Okay? Especially important when you have triangles that, for example, actually, let me see if I can get this to do this right. That didn't quite work now, did it? When the two triangles aren't exactly lined up the same way on the page. You know, before I moved them, it was really easy to see, top, left, right, all that. But when they're all spun around or flipped or something like that, using the tick marks is a big deal to help you write the similarity statements. Okay? So let's write a similarity statement for this. Triangle PRQ would be similar to who? P goes to who? How do you know? Right. The single tick mark on P tells you to go to the single tick mark at V. And then R goes to, I got like 2 people in class today. And then Q goes to S. All right. So tick marks are critical. Okay. Now, let's do a proportion statement. So this is a similarity statement. So and let's do PR, RQ, and QP. Who does PR go to? Yeah, now you see at this point, using the similarity statement is probably even easier than going to the picture and figuring out where everybody goes. Okay, the similarity statement is a very useful tool. PR goes to, say it again, VT in school. RQ. He's right. TS. And the last one? QP? SV, right. Good. Under control? All right, now let's actually use it. Oh, oops. Changed my mind on that one. All right. So we got to find x. How do you want to start? Well, here's a good question before we even begin. Who does x correspond to?
What was the question?
Who does x correspond to? Which one? Look at the tick marks. The tick marks help you. X goes from a single tick to no tick. QP. A single tick to no tick, or PQ. Using the tick marks help you. Okay? I mean, because especially when they're spun around, weird looking, different sizes, different orientations, who knows? The tick marks give it away. So because it went from single tick to no tick, we go from single tick to no tick. Tick to no tick. Okay. You see? That's the key. Make sense? So x over 21 would be who? Now we got to pick somebody else. So I chose right over left. So pick something from the right and put it over something on the left. You want to do 6? Let's do 6. 6 goes over who?
6 goes over. Yeah, what you can.
How did you know? Hmm? Well, how did you know? You could have picked the 15. But you chose to pick the 12, which was right, but I want to know why. The tick marks. The 6 goes to the 12 because of the ticks. It's between the double and the single tick marks. All right? Cross multiply and solve. Find me my x. What's my x? Good? Solid over there? All right. We good? Everyone got it? Nice. All right. One last thing. So you'll get these kinds of problems from time to time. Yeah, you have a small assignment tonight. All right. Um, all right. Oh, and I need to give markings. Before we even go anywhere, does it matter that I've only know that 2 of my angles are congruent? I mean, do I need to have all 3? Why not? To prove congruence, but I only have 2 right now. Well, do we know that C and F are congruent? Why? Well, C looks like it's supposed to be congruent to F, right? But we don't know it. Is there any way that we could, yeah. Yeah, we have the tick marks on the other 2. There's no tick marks on it, right. But we do know the other 2, right? So whatever they are, we know that they are the same 2 angles in the other triangle, right? Excuse me. We good? Okay, nice. Whatever those first 2 angles are, they're the same in the other triangle. So what do I know? Those angles in each triangle. What happens? What do we know about that? No. Angle A, angle B, angle C. What do we know about all 3 of those angles? It's true for any triangle. What do we know about all the three angles of a triangle? What do they add up to?
Oh,
Right. So whatever A and B are, they're the same as D and E. And if I subtracted them from 180, they would be equal because no matter what A and B are, I subtract them from 180, I get C. And then I subtract the same two numbers, which are D and E, and I get F. So all I really need are two angles in order to be similar. Okay. Now, if they're similar, then the scale factors have to be the same. You can't blow up something twice as big for one side and then 3 times as big for the other side. Everybody has to be the same times as big as his neighbor. So let's set up a proportion statement. 9 over what? 9 goes over what? 21 goes over 18 goes over. Now, by the way, when you're doing these proportion statements, one way that you can tell that you're on the right track is the numerators all come from the same triangle. Look, 9, 21, 18, they all come from the same triangle. And look at the bottom one, 15, 35, 25, they all come from the same triangle. Okay? If you have them all staggered in the wrong way, then you know you're going to make a mistake. Okay? And it's true for the other ones. Let's go back for a second. Look at those. The PRQ, all three of these numerators, and all three of these denominators, they come from the same triangles. Okay, so that's a good way to get yourself on the right track. Make sure you're not making a mistake that way. Okay? Good? All right. So let's find out. Or not. Go to your calculator, find out what all three of those fractions are. You can use the math enter to reduce your fraction, or you can keep it as a decimal if that's enough. What's the first fraction equal to?
Yo, equal. Just said this. 9 divided by 15.
What does 9 divided by 15 equal?
They're all the same. No, not. 9 divided by. No, they're not all the same.
The third one messes up. You can use math enter to get those fractions. So 9 over 15, get your 0.6 and do math enter. What do you get? 3 over 5. The next one. What's this one? And the last one. Yeah, what's that? Does that reduce? Doesn't work, does it? No, it's not the same. So if anything is wrong with this, then the whole thing doesn't work. They have to be exactly the same numbers all 3 times. This, my friends, is your scale factor. Please don't break my calculator.
Sorry.
Okay, that's how you find the scale factor. You take 2 objects, as long as they correspond to each other, and you divide them. And that'll give you your scale factor. And if all of your scale factors are the same, then the triangles are similar. Okay? If any one of them is wrong, forget it. Fails. Okay? All right. So I have a short worksheet for you guys to work on. You'll probably be able to knock out all, if not or most, if not all of it, before the end of the block. And this episode of the Ronco Show has been brought to you by Similarity and Proportionality statements.